Answer on this one is 1. Answer is 123. Answer is -3. Answer is -40. Answer on this one should be -2. Pick a number from 1 to 10 and drop it off. The winning numbers today are 10 and 8. The objective today is to use linear regressions on the TI-83 to answer questions about future predictions. I can use the correlation coefficient and the coefficient of determination in problem situations. You have two lists of numbers here. You have hours studied on the left and the test grade that corresponds to those number of hours studied on the right. You must enter those into list 1 and list 2. We'll go ahead and do that now. Video for today is also going to be on a separate video, which is of the calculator screen. It'll correspond to this, so you'll have to go to that separately to see what happened on the calculator instead of screenshots. Next, you want to turn on diagnostics by hitting second 0 and then the X inverse button, and then arrow down to diagnostics on. You must do that because if you don't, then you're going to end up with no R and R squared in your final results. And that usually leads to questions of, why don't I have that on my screen? This is the reason here. Second 0, X inverse, arrow down to diagnostics, and then hit enter and enter again. Now we want to use stat calc number 4 and then linreg. The three things that you're going to have to type in are the following. In addition to linreg AX plus B, you're going to have to type in L1, comma, L2, comma, and then you have to put a Y1 in there. In order to get a Y1, you have to hit the VARS button, which is just below the down arrow to the left of it, VARS. You'll get this screen, and then right arrow to YVARS. It's already on function when you get there. Hit enter, and you'll see all of your Y values. What you want is Y1 just to start with. Hit enter, and that's everything you need on that. And now you'll hit enter and find the results of it. Of course it says Y equals AX plus B. That's to remind you of what you've done. And then you'll have the coefficient of X, which is 7.6 and so on. And then you'll have B, which is the constant. That's what you add to it, which is 50.4 rounded. The R squared and the R are the following items. Let's go back and list these really quick. And we're going to round. For A, we're going to make it 7.61. For B, it's 50.45. R squared is 0.985, and we'll make that 6. We'll go 4 places on that. And then for the R, we're going to have 0.9928. Here's what each of these mean. The A is simply a coefficient. Need a smaller pen. There we go. Simply a coefficient on the X. The B is the constant. It's the y-intercept, just like in Algebra 1 on a graph. But the R squared is the coefficient of determination. This will give you an idea of how strong a possibility it is to predict with this equation we have just generated. And think of this as a percent. If you multiply this by 100, you can think of it as being a 98% chance of being accurate by using this equation to predict, for example, if you studied for 10 hours, what would your grade be? And then the R is how strong of a correlation the two lists have to each other. It can either be very strong, very weak, or it could be somewhere in the middle. For example, we have 0, +1, and -1. Those are the boundaries for R. If it's all the way over to this area, if you have a perfect 1, then it is a perfect correlation. All the way back to -1, it's going to be a perfect negative correlation. If it is 0, then there is no correlation whatsoever. This is a perfect positive, perfect negative, and no correlation in the middle. Now, of course, when you're in this area here, you have the option of thinking, well, let's say if it's 50%. Well, it could be right, it could be wrong. If it's in this area, you're getting more right than wrong. This area, more wrong than right. Generally, we don't deal with anything over here except in rare occasions. Most of them are going to be in the positive area. But in some cases, you do have a strong negative correlation, which can help you as well, but we won't do as many of those. Okay, so next, what we want to do is try to predict. Let's say we have somebody who studied 5.25 hours. What would their grade be? This is how you're going to find it on the calculator, which we'll switch to the other video now. So with our calculations, we came back with 90.38 would be a grade for that student if they studied for 5.25 hours. Again, the video from the calculations is on a separate video on YouTube. Practice problem. Here is practice problem number 1. We have students who studied the following hours: 0, 9, 7, 3, 2.5, and 8. Their test scores came back to be the following. This one was 33. This one was 105. This one here is 78. This is 47, 36, and this one had an 89. You want to store these in L1 and L2, and what we're trying to answer is the following question. If a student studied 6.75 hours, then what is their grade likely to be? The solution for this problem will be displayed on the calculator screen, which is in a separate video. And the answer to that problem was 79.70. Again, it's on the other video. The homework assignment for tonight is the following. You have 2 lists of numbers to type in, and you have 10 questions to answer about it. Number 1, I need the coefficient, I need the constant, the coefficient of determination, the correlation coefficient, which is R, and then from 5 through 10 you have predictions to make based on that equation. Pay attention carefully. On number 1, your answer must be rounded to 2 places. And then on number 2, 2 places. 3, we'll go 4 places. 4 is 4 places. And on 5 through 10, the answer is rounded to the nearest hundredth, which would be 2 places.